Okay, we are going to look at solving equations that involve fractions. Now, a lot of people don't like to work with fractions because it can be a little bit of a pain. Sometimes we just turn them into decimals because then we don't have to deal with the whole numerator-denominator deal. But I want to show you something, because if you look at this example here, it says x plus 8 over 5 equals 4. And we might be turned off in that x plus 8 is over a fraction of 5. But I want to show you something here. We know that 1/2 is equal to 2/4, two equivalent fractions. Now, when you have two equivalent fractions like that, we can go on the crisscross, I like to call it. 2 times 2, which is 4, and 1 times 4 is 4. See, that works because the fractions are equal. So if we go back to this example here, and I'm just going to change my ink, x plus 8 over 5 is already a fraction. I can easily make 4 a fraction over 1, and then I can apply that same principle. I can go 1 times x plus 8, which is just x plus 8, and 5 times 4, which is 20, and then there you go. It is an equivalent version of that same equation, and then I can do the opposite and balance. My fraction problem is over. Likewise, for this question here, I got 3 over 4 bracket x minus 1 equals 6. If I wanted to, I could expand by 3 over 4. I could change it to decimal 0.75 if I don't like working with the fraction. A couple different things I can do. However, what I can also do is I can take that 4 and I can slide it underneath the x minus 1. This is still an equivalent version of 3/4 times x minus 1. And now I got a fraction over 4. I can make 6 a fraction over 1 and do that exact same cross multiplying. 1 times, nothing changes, and fraction's done. I'm on my way. Actually, this one here, I can multiply through. I'll just finish it over here. And go ahead with my balancing. And I think this one's going to work out to 9. I'm just going to block that off so I don't get it confused. My next one. And again, this one here, it's already a fraction over 3 equals a fraction over 5. Perfect example. I got equal fractions. Put some brackets across those numerators. So 5 times x plus 2, so I'm not going to be in a hurry and multiply it out right away. I'm just going to get it ready to multiply. Same thing with 3 times 3x minus 2. And then we're going to expand. And of course, balance. Lots of prior videos on balancing, so I'm isolating 4x. And if I did that right, x is 4. So that is a way you can solve equations that involve fractions if you can get it to when they are two equal fractions, and then you can use that cross multiply principle and then go ahead and balance before. Or you can actually work with the fraction. You can multiply through by the fraction, change it to a decimal, a number of different ways you can go about it.